Hello, my 1C class. It's a time for the lesson again. This lesson is for March 17, which is tomorrow. March 18. I'm sorry, March 18. I forgot to erase from my 1B class. So this is 1C, March 18. Okay. And today we're gonna. This is for 13.4. So on 13.4, we're going to learn a couple new things. But before we start it, we're going to recall a 1B first. 1B, we learn two dimension. Okay, if we have a graph, a function of the graph, this is a graph right here. So this is for this graph here. Okay. And let's say if a point here, and let's say it's a point P, and through P you can draw a tangent line, okay, tangent to the graph at the point P. Now if this point is X, okay, and then if I'm going to go a little bit more, so delta X here, so this is X plus delta X. Then on this point here, now this is this one, that's your Y, and then on this one here, okay, that would be your y plus yx, y plus a delta y. So you can remember in 1b, now for the tangent line here, okay, this is an x here also. For the curve is also x. And when you come here, x plus delta x, if you go up, touch this point, and then you go up more, touch the tangent line, this distance don't change, okay, all the way. So this is a delta x. And it's also equal to ds. Your ds come from the tangent line, okay? So ds come from tangent line, delta x come from the curve. So this distance is same as this distance and same as that distance. And then for delta y, there's a little bit difference. Delta y is right here, but dy is right there. Okay, dy is already touch this point. And so dy and delta y, dy is a little bit longer than delta y. But still they're very, very close. Okay, and we call the delta x, delta y, we call the increments for x and increment for y. For 1C, for 1C, okay, for 3 dimension, we're going to learn what's the increment for 1C, okay, for 3 dimension. And if G is equal to fxy, so that's a plane, a surface, the increment for G is x plus delta x for the first point, y plus delta y, and then subtract the original one, x and y. It's very hard to draw 3 dimensions, so I couldn't draw it, but 2 dimensions you can see. Okay, delta x dx, delta y dy, and they're very close to each other. So our goal is, do you think delta g will equal to dg? Okay, so here's our goal. It's a delta g approximate to dg. So, and that's the formula for increment for g. Okay, now differential for x, this is a definition. Okay, definition means that you take it as it is. Differential of x is a dx equal to delta x. Differential for y is a dy equal to delta y, because you can see in the picture they're really close. Okay, this is definitely equal and this is approximate actually, but it's close. And total differential, now this is a new term you learn. Okay, it's called total differential. Why they have to call total? Because if you just differentiate the x, it's a f of x, that's a partial. If you just differentiate the y, that's fy, that's also partial. When you add them together, that becomes dg, that's the total. Okay, so that's how they go. So partial and partial together become total. So that's what they mean. Okay, so that's the new term you learn, increment for g, okay, and total differential for g. Here's the 2 formulas. So please memorize the 2 formulas. And then now we're going to learn how to use these two formulas, okay? So let's see how to use them. And let's look at a couple problems. And here's a problem number 8. And we are given a function w equal to x plus y over z minus 3y. Okay, what they want is that they want to find the total differential for w. Okay, total differential for w, they use a notation of dw. This means a total differential, okay, and which is equal to the partial for x, wx, and then dx, and then plus partial for y, wy, dy, and partial for z, wg, dg. And these all together makes a total for w. So now we're going to start one at a time. So let's go wx first. Wx means that x counts as a variable, rest counts as a constant. So this is same, so you can look at this as 1 over z minus 3y, that is your coefficient, and then take the derivative of x plus y, okay, and that comes out equal to, like that's just 1, that's a 0, because that counts as a constant, so it comes out equal to z minus 3y. So that's wx. Let's find wy. Wy will be, there are two of them now, so the quotient rule here, okay? We got 2y here, one's on top, one's at the bottom. So it'll be x plus y prime z minus 3y minus x plus y z minus 3y prime over z minus 3y squared. And you can see that just 1 here, so just a z minus 3y. Subtract, and you keep this 1, and then these are just equal to negative 3, okay? So 2 negative become positive, so become plus 3x, and then plus 3x here, so plus 3y, over z minus 3y squared. And cancel these are 2, okay, I think that's all we have. And then that's equal to z minus 3x over z minus 3y, and then square. Then we go for the wg. Wg, that means there's only one z here, okay? So this counts as a coefficient. So that will be negative, okay, x plus y z minus 3y squared. And chain rule, this one just equal 1. So how do I get this one here? I basically use this way, okay? 1 over x is equal to negative 1 over x squared. So I just use that, okay? So I treat this as like a big chunk of x. So 1 over that square, and this is a coefficient, so I put back the coefficient. And inside chain rule, but then chain rule for z just equal 1. So at the end, I just substitute this back in here, okay? So I'm gonna go, this, I don't have enough room, so I just put in, this becomes 1 minus z minus 3y, okay? I just replace wy equal z minus 3x over z minus 3y squared. And then wg equal to negative x plus y over z minus 3y squared. Okay, so that's how you do these problems. And you leave the ds, dy, dz alone. So that's for problem number 8. And now we're going to go to number 10. Number 10. We are given a function f of x, y equal to x squared plus y squared. And here's what they said, okay? They said x is going to go from 2 to 2.1, and y's go from 1 to 1.05. They want to find a couple of things. First one, they want to find delta z, okay? And by the formula we have earlier, delta z is equal to f x plus delta x, y plus delta y, and then subtract f x y. So now we're going to get one at a time. So let's get this one first. So f, your 2's go from 2 to 2.1, so that's your 2.1 is right here, okay, 2.1. The delta s is equal 2.1 subtract 2 is equal to what? 0.1, so delta s is 0.1. But they only gave a, now this one is x here, this is x plus delta x, okay? This is y plus delta y. So they gave to us already. So 2.1 and then 1.05, subtract xy, 2 and 1. So we just have to put into the formula, okay? So that'd be 2.1 square plus 1.05 square, subtract, and then now put the 2 and 1 inside, 2 square plus 1 square. And use the calculator, it comes out equal to 5.5125, this one. Subtract this one, I get is equal to 5. So approximately equal to 0.5125. Okay, so that's how you do this one. Now, number B, they said find dz. dz means a total differential. Total differential. So that will be equal to f x dx plus fy dy. Well, look at f of x. F of x, that's equal to 2x dx plus fy equal to 2y dy. And we know that in 1b, we only know that by definition, your ds is equal to delta x. Okay, so ds equal to delta x and dy equal to delta y. So let's see, so 2 times 1, so 2 times your x equals 2 times 2. Your ds is same as delta x. You can see delta is equal to 0.1 plus 2 times y, so 2 times 1. And your dy is the same as delta y is equal to 0.05. Now if you go from 1 to like smaller number than 1, then your delta y will be negative. Okay. So calculate this. It comes out equal to 0.5. And so you can see that delta z here, and then these are really similar. Okay, they're almost equal to each other. Close enough. So that means delta Z is that's approximate to dz. Okay, so that's our goal to find out. And that's how you do number 10. I just want to tell you, if you go, let's say if you're going to 1 to like 0.95, okay, then your delta y will be negative now, because you take 0.95 subtract 1, so it's equal to negative 0.05. Okay, so your delta can be negative. So that is for number 10. Negative means you are shrinking, okay, and positive means you increase. You expand. And let's try point number 16. We are having a expression 1 minus 3.05 square over 5.95 square. Subtract 1 minus 3 square over 6 square. They want to approximate this answer, okay, approximate the answer. So in the old time, when people want to do approximation, okay, so what they do is that, so what's the difference between this, subtract that? So what they do is that they're going to write an expression first, okay, write a function out. Usually the one that in the back, okay, that's your original function. So this s is a f x y. You can treat this as an x here, and that's your y. And then I use, this is not x, this is 1 here. This is x, and that's your y. So your fxy equal to 1 minus x squared over y squared. So you can write out your expression this way, okay? So now we need to find, so that's my, let's say that's my z. So they want to find out what's the dz equal to actually. So what's the difference, right? This subtract that. Then let's see, okay, now your x is from 3 to 3.05, because this is an earlier one, this is a later one. So your delta x, same as dx, equal to 0.05, okay? And then your y is from 6 to 5.95. You're actually shrinking. So your delta y will equal to dy equal to negative 0.05. Now we're going to get the total differential. So dz equal to f of x dx plus fy dy. And your f of x will be this kinds of coefficient, so 1 over y squared, okay? And that's a constant is 0, that's a negative 2x dx. Plus the y, this is kinds of coefficient, okay? 1 minus x squared. Take the derivative, this is y to negative 2, so negative 2. Take the derivative, so y negative 2 minus 1, and then so y to the negative 2, take the derivative, so equal negative 2y negative 3, okay? So that become negative 2 over y cubed, and then dy. Now you just need to substitute the number inside, okay? Your x equals 3, your y is equal to 6, so put it all inside here. So y is equal to 6 squared, 2 times 3, your dx equal to 0.05, plus 1 minus your x equal to 3 squared, negative 2 times 2 over 6 cubed, dy is equal to negative 0.05. And guess what? This is not easy, I feel like. It comes out equal to negative 0.012. I didn't say this way is easier, then you would just put in the, just to calculate that. But that's how they think it's easier. So I guess in the old time, that's how people believe. So that's number 16. Now we're going to do a couple application, use this. That's a little bit helpful on that one. The application, I'm going to show it to you. Okay, so here is a problem number 24. On number 24, you are given a cylinder. They said there's an error between the diameter, so this is a D here, diameter, okay, this is D, and that's the center, okay, and then there's an H here. They said that the area for the diameter is same as the area for the H is equal to plus minus 0.05. Means it can expand 0.05 more or shrink it 0.05 more. So DH is the area, okay? And then now they said that R is equal to 3 cm. And they said that H is equal to 10 cm. The answer was your dV, okay? And then they also answer another thing. I will show it to you later on. So the answer for this is total area. So this will be, that means this is going to be the volume for R. They want D, so they give a D, so D and DT plus a V, H, and then DH. So that's the formula. So that becomes the area for the volume. Now our goal is to find out what's the VD and VH, okay? So remember the formula for the cylinder? V is equal to what? Pi R squared H. Well, I don't have the area for R, but I have the area for D, so I'm going to convert this. So that becomes the pi R is equal to D divided by 2 square H. Okay, so that's equal to pi D squared over 4H. And now I'm going to put the 4 and the pi together, so I have D squared H. Because these are two of the variables, I put it on the side. So VD means to take the derivative D, okay, so that equal to pi 4, H don't change, and then 2D, and then DD. Plus, take the derivative for H, that will be this one change, and rest of don't change. That's just a coefficient. And now we're going to put the number inside. Your H equal to 10 down by 2. Your D is equal to 6. And DT equal to plus minus 0.05. And then add 2. So I'm going to put it down here. Power 4. Your D is equal to 6 squared. DH also equal to plus minus 0.05. And after you simplify it, okay, this is approximately plus minus 7.8. So you can see that if you made a little mistake on the diameter, little mistake on the H, look at that little mistake, but comes to here, it becomes a lot bigger mistake for H, for V, for the volume. So that's the first part. Second part, they want to know how big this volume is compared to the original volume, Okay, this is the area for the volume. So this is the area for the volume. Now they ask you, what is the relative volume? Okay, goodness. Relative area for V. So that means that relatively speaking, this volume compared to the total, how big it is going to be very important. So they ask you for dV over V actually. So that will be plus minus 7.8. And then pi, I need to finish this part, okay? So it will be pi over 4 times pi r squared, yeah, power 4 times by d is equal to 6, and times by d is equal, or d squared, so 6 squared, so times by h is equal to 10. It comes out equal to, or pi r squared, oh, sorry, pi r squared, I put the d here. V equal to pi r squared, oh yeah. V equal to pi r squared h, so I don't have to use that. My pi r squared h, so be pi, my r is equal to 3 squared, and then h, 10. Like this better. It comes out equal to 2.17. So means the volume is 2.17% more than it's supposed to compare the area. So the area inside here, relatively speaking, is only 2.17%. That's not like too bad, but still. So compared to the total volume. So that's for point number 24. And I have one more problems, okay, for this session. And that's the point number 30. They said there's a acceleration. This acceleration, okay, is proportional to the v squared over the radius, okay. So here's the formula for it. They said the percent of error in V, this means the relative error, okay? Now the one we did earlier, the previous problem, the answer, we're looking for relative error. This time they gave that to us. They say in V, that will be your dV over V is actually equal to 3%. And then they said the percent of error in R, they said it's a dr over dt, dr over R is equal to negative 2%. Why is it negative here? Now be very careful. Why is it negative? Because this one's an inverse to here. This is an inverse relationship. So when you're inverse relationship, you need to put a negative for that one, okay, for the inverse one. For this one, it's a direct, you don't need to put negative. The one on the top is direct, you don't need to put negative. But for the bottom one, it's the inverse, so you have to put a negative here. They ask you to find dA and then dA over A. Okay, they want to find two things. Well, dA just equal to what? AV dV plus AR dR. So respect to V is just equal 1 over R. Okay, dV plus AR is just equal to what? Negative V squared over R squared dr. And So that is for 2v. So that's for dA. And then now we're going to go for, oh yeah, we can put in the number inside. Okay. So the dV is equal to, oh, we don't have dV yet. Okay. So now we're going to go dA over A.